Hello, welcome to this next session on computer codes. In this session, we'll discuss what is known as the Excess-3 code. What is the Excess-3 code? Excess-3 code is a non-weighted code. We know that a non-weighted code is one in which the position of the bits do not have a specific weight. It's a binary coded decimal, and this binary coded decimal is also popularly known as a form of a BCD code. Now, there is a normal or a pure form of BCD code which I have discussed in another video, and this Excess-3 code is a modified form of the BCD code. This code is also a self-complementing code. Now, here are the steps to convert a decimal number to its Excess-3 equivalent code. So as the name indicates, this is an Excess-3 code. So what we do is we take each digit of the given decimal number and add 3 to it. And that is from where the term Excess-3 code comes. So each digit we add 3 to it. We write each of the new digits in the form of 4 bits. And the resultant number that we get is in binary, of course, but this number is called as the Excess-3 code. Let us take that example. In this first example, we'll see how to convert the decimal number 457 into its Excess-3 code. So we start with a given decimal number. The digits of this number are 4, 5, 7. We add 3 to each of the digits. So we add 3, 4 plus 3, that gives us the sum 7, 5 plus 3 gives us the sum 8, and 7 plus 3 gives us the sum 10. So we are not adding plus 3 to the entire number, we are adding plus 3 to each of the digits. Now once we have this, we'll convert each of these decimal values. Each of these decimal values, we'll convert it into an equivalent 4-bit binary value. So the value 7, decimal value 7, is converted into 0, 1, 1, 1. 8 becomes 1, 0, 0, 0, and 10 becomes 1, 0, 1, 0. And therefore, 457 of decimal is equivalent to 0, 111. That's this one. Then we have 1, 3 times 0. And then we have 1, 0, 1, 0. 1, 0, 1, 0, and this is in Excess-3, and this is usually indicated by writing the subscript XS-3. Let us take the next example where we are converting a decimal number which has a decimal point, for example 17.32. We will convert it into its Excess-3 code. Now the process is identical. So we take each digit 1, 7, 3, 2. To each digit we will add 3. So we add 3 to each of this. Observe that here we have not indicated the decimal point. We are just indicating the digits, and we'll take care of the decimal point towards the end of this. So we have 1 plus 3, 4, 7 plus 3, 10, 3 plus 3 is 6, and 2 plus 3 is 5. Now once we have this, we'll convert each of these decimal values. So we convert this into its equivalent 4-bit binary. So 4 has the equivalent value 0, 1, 0, 0. Similarly, 10 has the equivalent value 1, 0, 1, 0. 6, its value in 4-bit binary is 0, 1, 1, 0, and 5 is 0, 1, 0, 1. And therefore, 17.32 of decimal is equivalent to, so we have 0, 1, 0, 0. This is the first part. Then we have 1, 0, 1, 0, the second part. Now after this, we have the decimal point in our original value. So we write the point. This is the radix point. 0, 1, 1, 0. This is 0, 1, 1, 0, and followed by 0, 1, 0, 1. This becomes the value in Excess-3 code. Now here is the table of decimal values, the equivalent BCD code, and the Excess-3 code. Now here is something essential and very important to observe. For each of these, we can see the excess code is given to us. So if we start with the decimal number 0, now let us observe. The decimal digit 0 has the BCD code 0000. The Excess-3 code is 0011. Now the question arises, how did this become the Excess-3 code? So here it is. We take 0. Since it's an Excess-3 code, we add 3 to this. This gives us the decimal number 3. This is the decimal number. And when we convert this decimal number into its equivalent binary value, the binary value becomes 0011. This is in terms of 4 bits. Let us take the number 1. This 1 can be written as, to calculate the Excess-3 code, we can write it as 1 plus 3. This is equal to 4. We are adding this plus 3 here because we want to find the Excess-3 code. So we get 4. And this 4 now of decimal is equivalent to 0100 of binary. That's how we have calculated the values for all from 0 to 9. Now observe this. The bit pattern 0000 is not used in Excess-3 code. So nowhere we have 0000 in none of the positions we have, because even if we start with the decimal 0, its equivalent to calculate Excess-3 will be 0011. And again observe that the bit pattern 1111 is nowhere used in the Excess-3 code. Now what is the self-complementing property of the Excess-3 code? Excess-3 code, we say, is a self-complementing code. What it means is that the ones complement of the coded number will give us the nines complement of the number itself. Let us understand what we mean. Let us consider the decimal number 2. We have the decimal number 2. This decimal number 2 can be written in binary as 0010. Now, the Excess-3 code for 2 will be 2 plus 3, 5, which is 0101. So 5 can be written as 0101. So this becomes the Excess-3 code. Now let us halt here for a minute. Let us halt here for a brief moment. We started with the number 2, which is of decimal. If we want to find out what is the nines complement of this, we know that the nines complement of this will be 7. This 7 plus 2 gives us 9, and therefore we say that this 7 is nothing but the nines complement of 2. Now let us proceed from here. We started with the number 2. We got the binary value as 0010. We want to find what is the excess code of 2, Excess-3 code. So the Excess-3 code of 2 we find by adding 3 to 2. 2 plus 3 is 5, which can be expressed as 0101. This becomes an Excess-3 code. Now let us take this number itself, 0101. If we take its ones complement, then we just have to complement each of the bits. So 0 becomes 1. The 1 flips over to 0. 0 here flips to 1, and 1 becomes 0. So we have the ones complement is 1010. But if you observe this, 1010 is the excess code for 7. And this 7 we said is nothing but the nines complement of 2. So we have here the ones complement of the coded number. So our coded number is this. This is our coded number. Its ones complement. That means if we take the ones complement of this, we get this. And this is nothing but the nines complement of the original number, that is number 2. So this is the idea behind self-complementing property of Excess-3 code. Let us take a third example, and here we are doing a reverse example where the Excess-3 code is given to us and we want to calculate the decimal value. So let us start by first writing what is the Excess-3 code. The code is 0110, 1001, then we have 1010. Now what we'll do is first we'll express each of these 4 bits in terms of its equivalent decimal value. So this becomes 6, 1001, this becomes 9. We know that the weight of this bit is 1, the weight of this bit is 2, weight of this bit is 4, 8. Since these two bits are 0, the values cancel out, and therefore what we are left with is 8 plus 1, that gives us 9. In the similar way, 1010, it will have a decimal value of 10. Now we are told that this is already an excess-3 code, and therefore if we want the decimal value, what we do, we will now subtract 3 from each digit. So we take the excess-3 decimal value. 6 minus 3, 3. 9 minus 3 is 6, and 10 minus 3 is 7. And therefore, this excess-3 code, the original excess-3 code, is equivalent to 367 of decimal. Let us take one more example where we are converting a binary number to its excess-3 equivalent. We have a binary number here 1101, and we want to calculate the excess-3 code. So now the steps will be like this. We will first convert the given binary number to its decimal equivalent. So we have 1101, that becomes 13 of decimal. Again, we know since this is a binary number, each bit has a weight assigned to it. So the weight of this we've already seen is 1, 2, 4, 8. Wherever we do not have a bit, like this bit is 0, so we can cross out this, and therefore what we are left with is 8 plus 4, 12, plus 1, 13. So 13 becomes the equivalent decimal value of this number. Now here is the decimal number given to us. We will now convert each digit of this to its 4-bit value. So 1 can be expressed as 0001. So the 1 has been expressed as 0001. Now come to the digit 3. This 3 can be expressed as 0011, and this becomes now the equivalent excess-3 code, and therefore our excess-3 code, now this is the BCD digit. Mind you, this is the BCD digit. The corresponding excess-3 code, we will get it from the table. So corresponding to this BCD code, the equivalent excess-3 code is 0100. Corresponding to 0011, the BCD code, we have the excess-3 code as 0110, and therefore our given binary number can be expressed as 0100, 0110. This becomes the excess-3 code for the given binary number.